In this experiment, we'll be using an E over M apparatus. This E over M apparatus has some Helmholtz coils wrapped around. Current through those coils will create a nice uniform magnetic field. Inside the coils is a glass tube, and inside the glass tube is a cathode ray gun and a glass rod that is calibrated in centimeters. Now we align this E over M apparatus with the Earth's magnetic field, so the Earth's magnetic field does not affect the cathode rays. Also required in this experiment is a power supply. This power supply contains 3 separate power supplies. The one on the left to heat the filament to create the cathode rays, the one in the middle to accelerate those cathode rays, and the one on the right is for the Helmholtz coils. Sending current through those coils will create a nice uniform magnetic field. Now the current going through the Helmholtz coil will be traveling in this direction, conventional current. Notice there's 2 coils, one in front of the tube and one behind the tube. And using your right-hand rule for solenoids, that means the magnetic field in the coils will be away from you. Now with the heater turned on, you can see the electrons produced by thermionic emission, and with a small accelerating voltage applied, they accelerate out of the electron gun and into the glass tube. Now a small amount of gas in this glass tube allows us to see the beam of electrons, and as you can see they are traveling straight down. Now when we turn on the uniform magnetic field by sending 1.75 amps of current through the coils, they travel in a circle. Now by adjusting the accelerating potential, we change the speed of the electrons, and they travel in different radius paths. Here you can see the electron beam traveling in a circle. This electron beam has a diameter of 5 centimeters. The accelerating voltage on our voltmeter is 132 volts. You can see as we increase the voltage, the diameter and therefore the radius of the electron beam increases. Here the electron beam has a diameter of 6 centimeters, and the accelerating voltage is 176 volts. Increasing the voltage again, the diameter increases. Here the electron beam has a diameter of 7 centimeters. And the accelerating voltage is 229 volts. Here's the electron beam with a diameter of 8 centimeters. And the accelerating voltage is 292 volts. Here's the electron beam now with a diameter of 9 centimeters. And the accelerating voltage is 359 volts. Here the electron beam now has a diameter of 10 centimeters. And the accelerating voltage is 441 volts. And here's our last trial with the electron beam with a diameter of 11 centimeters. And the accelerating voltage is 527 volts. Now, with this data and the lab sheet that accompanies this video, determine the charge to mass ratio for electrons in this tube.